lesson 8. So, this beginning part is just a review of the things we've gone over. Just telling you that the vertical stretch looks like, what the horizontal stretch looks like, the translations, just all good review. So if you want to highlight a section, just something to go over, that's good. One thing we got to make sure, which we're focusing on today, again, that's today's standard, is that we're doing the order in which we do these combinations, okay? So sketch original function, sketch any stretches, sketch any reflections, sketch any translations. Remember, stretches and reflections aren't super important to have the order, but if we stay at that order, you should be good every time. When I was working this morning with a student who was asking questions is, if they tell you to do a specific order, then you do follow what they say. Okay? However, if they put you a list of things to just do, you need to follow this. Okay? So keep that in mind. If they do say, move this 3, then reflect, then do what they say. Okay? So let's look at this one to start. Again, today, a lot of questions if we got them, guys. All right, so consider the function defined by the equation 2 of f 1/2 x plus 5 minus 8. So we got a lot going on there. Okay, so it says if the equation is written in the form of state the values of a, b, h, and k. So we're just kind of identifying our stretches. So for example, for this one, a is 2, right? B is 1/2. Those are my stretches. H is, we say -5, right? And K is -8. So now write the transformation associated with the parameters of A, B, and H. So what the transformation is, A is vertical stretch 2. B is horizontal stretch 2. H is, sorry, oh no, sorry, let me rewrite that. Forgot how big that was. Getting all over the place. Let's make that smaller so we avoid that later. All right, so rewrite this real quick. A is 2, B is 1/2. Okay, so A is vertical stretch 2, B is horizontal stretch 2. H is translation, horizontal translation, I'll put HT, of left 5. K is your vertical translation of down 8. Okay. So put these transformations in the order which can be used to sketch the graph. They are in the correct order, right? Stretches, translations. So you can just say order above. Okay? So order above. Okay, so let's sketch the graph. So let's see what happens here. So we got vertical stretch 2, horizontal stretch of 2. So let's do that. So that means we are going to raise our vertical stretch so that affects our y. Okay, so vertical stretch of 2, so like this point and this point are going to be there and there now. Remember, it doesn't affect 0, 0, right? So that 0, 0 is going to stay because 0 stretch is 0. So that's why I went to the next point there. So you see it got a little skinnier. Okay, if you're not seeing it, let's just do it one at a time, and I'll try to do little colors here again to help you. So this is the first. I'm doing the vertical stretch. This is what the vertical stretch looks like. Okay, so it got steeper. Horizontal stretch is going to make it wider. Okay, so the horizontal stretch is a little bit interesting because to see how the 0 here, it's nice to use x-intercepts, but if it's 0, that's not going to move at all, right? So you might want to use these ones instead, okay, to go ahead and stretch it out. So the horizontal stretch, if it's 1, it's going to be here. Okay, I'll do the stretches in red. Okay. Okay, so that would be, hold on here. We need to stretch. Yeah, sorry. We're stretching the new point here. So if it's here, it's going to be there now. Okay. Is that too hard if it's all red? All right, so this is the vertical stretch. I need to do a horizontal stretch to that vertical stretch. So if this is at 1, now I'm over here, right? I'm doubling. So now this is essentially where my new one's at. That's the green there is a combination of these two. So that's from here to here. Now we go horizontal translation left 5. So we're going to take the whole thing and move it left 5. So we'll go blue for this one. So we're going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And so we're here. And from there, we're moving what? Down 8, yep. 1, 2, 3, 4, 5, 6, 7, 8. 2, 6. So we are here now. That's our new image. Okay. Any questions? Okay, so now we're just going to look at the function parts. That's the graph part, the image part. Just because the red there might got confusing, just to make sure you're good. The first thing I did is I vertical stretched it, and then from the vertical stretch, I horizontal stretched it. Okay? Now you can do that either way. It's still going to be fine. I could have stretched it out and then stretched it up. They're going to land the same spot. And we learned that last lesson when we did stretch with stretch. Okay? So don't worry about order. So if you want to do horizontal stretch first, you still would have been fine. Okay? All right, so here we go. The original graph of y equals x squared. So that was the original graph of it. So we just want to talk about, well, if this is all the stuff that happened to it, what's that function now? So what's that look like now in terms of the function, not the picture? Okay, so write the equation for the transform function y equals 2f of 1/2 x plus 5 minus 8. Okay, so what should we do first? So I kind of like just to write it in. So what I'm saying is there's two ways I can do it. I can do what's happening to y, or I can just plug this stuff in. And so if we know this is y equals x squared, we know the vertical stretch would make it y equals 2x squared, right? And then we know the horizontal would make it like that. Okay. Plus, yeah, and so the x plus 5 would go in there. Yep. So I'm trying to see here real quick. Yeah. And so what happens there? So what happens here, we can go and simplify this, though, before we put the 8 and the 5 in. So what is 1/2 x squared? Right, so it's going to be 1/4 x squared, which gives us what? 2 times 1/4 is 1/2. And so that's simplified there. So we just simplified our vertical stretch and horizontal stretch. Okay? So they're still here. But once I did the square there, 1/4. Now, since that square's done, I can multiply these. 2 times 1/4 is 1/2. Do we have to do that? You could leave it, but the only thing about that is it gets a little bit messy. So it's kind of up to you what you want to do. And the reason that happens is because the vertical stretch and horizontal stretch, again, it doesn't matter order. So putting them together like that is just kind of making it clear where it's going to go. It's going to go there. Okay, but you can still do this. So like, Barbara, if you want to leave it, like this, but now you have to insert x plus 5 here, you can still do that. But see what I'm saying is it looks a little bit cleaner because I'm going to put this now. Right? And then I'm going to put minus 8. Right. Okay, and so that's done. This right here, if you put in your calculator, that'll be the yellow parabola I drew. Okay, that'll be the yellow parabola I drew. Any questions on that?
So if you're looking at that, if you just did half of a vertical, like that's just saying half of a vertical stretch.
Right.
So that's all you have to do.
For this one, yeah. That ends up being where it landed.
Oh.
Yeah. So she's saying the combination of that vertical and horizontal stretch ends up just being a half of vertical stretch. That's correct. That's correct. Okay. Anything else? So the other, well, I'm just going to leave it like that. I think that's fine. All right, we're good. All right, let's go to example 2. And so to verify, they're just saying you can put that one I said, and like I said, it should match that yellow image we had. Okay, we just have a couple more. So it's like a shorter lesson today, so that's good. All right, so the graph of f of x is shown. Sketch the graph of -2 f of x minus 3 plus 1. Okay, so go ahead and try that. So go ahead and do that. So actually, I'll help you. Let's label first what's happening. We have a reflect across the x-axis. We have a stretch, vertical stretch of 2. We have a horizontal translation plus 3, or right 3. And we have a vertical translation up 1, or plus 1. Okay, so go ahead and try those to that image and see what you come out with. I'll do that here in a second. I'll pause the video. It's fine. So I'm just going to go through this up there while you're finishing up. So I'll do a little bit colors again. So I'm going to do the reflect first. So the reflect puts that here. That stays there. That's there. That stays there. And that's there. Oh, nope, one more. 5. Okay. So roughly, it's going to be like that. After I do the reflection, okay, let's go to red here for the vertical stretch. So vertical, it won't matter.
It doesn't?
Right.
Okay.
Yeah. So you definitely can stretch first. I know that I guess they do stretches first. Sorry. I just do what I saw first. But if we get different, then we'll know. But vertical stretch of 2, so that's -4. So I'm going to be at negative 8. Okay, so stretch of 2, that's at 2, so it's going to be at 4. What do we got here? This one's at 5. So that's going to be at -10, so that's going to be off the page a little bit. Okay, remember, they're not going to change these, right? The vertical stretch won't change your x-intercepts, so it's still going to have those same x-intercepts. Okay. Now that's why they say about the x-axis, because you're stretching away from the x-axis. If you're ever sure, why is vertical about the x, not the y? Because that's what you're stretching from. Okay, so that's going to go like this. And then way down here like that. Okay, so that's what it looks like now. And then we're going to go right 3, up 1. So right 3, up 1 to finish. We can do these two together because they're translations. So let's go right 3, 1, 2, 3, up 1. Right 3, up 1. Oh, that's a different one. That's not the same one, sorry. That's the original. Got to go from the red line. So right 3, up 1. Right 3, up 1. Right 3, up 1. Can do this one down here. Right 3, it's up 1, still not quite there. Okay, so it's moved. Right 3, up 1. Oh, I can do this. Oh, I did this one too. Okay, yep. All right, so it's going to come down. So it's going to come down through, like so. It's going to bounce. I guess there's no arrows on it for us, so. Yeah, they're not going to look, I mean, mine doesn't look great either, so it's fine if yours look terrible. I'd say, are you in the right quadrant? Does it look about the right size? Okay, that's things I focus on. If your lines are obviously as bad as mine, that's not going to be taken against you. Okay, especially using this pen on here is a little bit harder, but that's the idea. Any questions on that, guys? Anything confusing or not making sense from that? Cool. All right, let's try this one here. Consider a function y equals f of x. In each case, determine the replacements for x and y, which result in the following combinations of transformation. The equation of the transform function is that form, so just the a, b, h, and k's. Horizontal stretch by a factor of 1/4 about the y-axis, and a vertical translation of 5 units down. So how would that one look? So this is a horizontal stretch with a vertical translation. So this is the one that they actually won't be affected because they're different directions. Okay, but we still want to put them in order. So when we put these in order, you're going to say, okay, horizontal stretch at 1/4, so we know that means we're doing this, right? 4x, right? Because horizontal stretch. And a vertical translation of 5 down. That's all that we're done. That's it. Okay. So this one, we do have two movements. And the way I kind of describe it is we have two movements of different properties. We have a reflection over the y, which is that a reflection of is that the horizontal reflection or a vertical reflection? So if it's a reflection in the y, so here's your y. It's a horizontal reflection, right? So I have a horizontal reflection and a horizontal translation. So what I'm saying is those are two different horizontal movements that are different properties. One's multiplication, one's addition, subtraction. So this is where we got to make sure our order is solid. We don't want to mess that up. This one's fine. Vertical stretch of 3/5. We're just going to say, okay, y equals 3/5 f of x. Now we're going to say y equals 3/5 f of negative x. Right? Because that's the flip over the y. And now we'll insert the last piece there. Two left. So it's going to be like that. You can leave it like that so you can see everything that's going on. Okay, but you could distribute the negative if you wanted. It's fine. But they left it like that so you see the flip and you see the +2. Okay. -2, yeah. Now see, this is very important actually, and I'm glad that, and I'm going to talk about this a little farther. When you see this, guys, that is still left 2. Why? What makes that left 2, do you know why, Travis? Take the negatives out, right? But really the question is what you plug in that makes it 0. That's what we're looking for, right? So like if I have x minus 2, we know if we put a 2 in there, what's 2 minus 2? 0, right? But if I put a 2 here, it's now -2 minus 2. So what do I need x to be to make my movement? Now I need a -2 again. So that it's still right 2. So what I'm saying is when you see a negative here, you have to flip your thinking. Okay, you have to flip your thinking. It's still going to be the left 2. All right, cool. All right. Thank you. Thank you. All right, last page. Here we go. Let's get this done. All right, function g of x is x cubed transformed into a new function, the form of p of x, and g of x is stretched vertically about the x-axis by a factor of 0.25, also known as 1/4, reflected in the y-axis and translated 3 units to the right. So write the new function for p of x. Okay, so g of x is what we're transforming to make a p of x. If you're confused on why do we have two functions, we don't have the p of x yet. That's our job. Okay, we are going to go ahead and stretch vertically. If you don't want to write 0.25, write 1/4. It doesn't matter. I'll just stay with 0.25. That's what's the problem. So I know that I'm doing vertical, so it's going to be first step, of g of x on my way to p of x, okay, is I'm going to say, okay, it's going to be now 0.25 x cubed. It is reflecting over the y-axis, so what's that going to do? So that's going to make it 0.25 negative x cubed. And what does that do? If you're cubing a negative, what happens? It's a negative now, so we can write this out here. Right? So it will be a negative x cubed when you cube a negative. And then our last piece, we are going to translate it to the right 3. The reason that's helpful to take that out, you're saying, why'd you do that? Well, because it gets me away from that opposite thing I was just talking to you about. So if you just understand why it was the opposite, now this is clean. What I mean by is when we put in the 3 units to the right, what should that be? If we want to move 3 units to the right, what do we put in? X minus 3, right? And that's all we put in now. So our last step for our p of x is going to be negative 0.25 x minus 3 squared, or cubed, sorry. And that's it. Everything good? Yeah, ask questions. Get the dialogue going. All right, 2 more here. One's not really a problem. It's just putting down the rules a little bit. All right, so one more of the pictures. Given the graph of, given the graph of y equals f of x, sketch the graph of the transform function of f of 1/2 x plus 3 minus 8. Rewrite this function in the form, okay? So that's the hint. So what do we need to do to rewrite that? Because you can see, what's kind of tricky of this one is, see how it 1/2 x plus 3? See how that's in a bracket there? They've kind of simplified it so we can't see what the movement of right and left was. So what I'm saying is that they pushed the 1/2 in. So I want to pull 1/2 out because that's the stretch. So I want to go pull 1/2 out. What's going to be in here now? If you pull 1/2 out, that's like timesing everything by 2. That's what you can't see. Okay, so let me state that again. I pulled the 1/2 out so we can see our stretch. All right. Pull the 1/2 out so I can see my stretch. When I do that, now I can see my translation. Okay? So remember, when you pull halves out or you pull fractions out like that, it's like multiplying by the whatever that is. If I pull out a third, I'm multiplying everything by 3. If I pull out a 1/12, I'm multiplying everything by 12. It's that same type of idea. And then minus 8 is still out here. So now it's in the form they asked me for, see? I can see everything now. So what's my A? A, there's just 1. There isn't one, right? There's no vertical stretch. What's my B? Right, your B is 1/2. I know it means that it's 2, but your B is 1/2. Your H is negative 6. And your K is negative 8. Okay, so let's go ahead and do these. So we don't have any reflections, so that's nice. Okay, we're just doing a little bit of movement. So let's do our horizontal stretch of 2. Let's do that first, since that's what we should do first. So we're going to do this guy first. So it's going to stretch by 2. So this is negative 2, so it's going to be negative 4. This is 3, it's going to be 6. Same thing here. This is 4, it's going to be 8. Okay, and then the y one won't move, and this one's going to be -6. Okay, so there's my outline of what this is like after we do our horizontal stretch. You can see it's been stretched horizontally, it's wider, so we feel good about it. Okay, now let's do our movements. So do these two together in green. So we're going to go left 6, down 8. Left 6, down 8. I'm probably going to be down here, right? Left 6, down 8. Okay, so this one's going to be off the page. 1, 2, 3, 4, 5, 6, 7, 8. So we'll just roughly put it down here just because we want to. This guy, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. This guy, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. We can do this one. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. And this one. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Okay. 4. Yeah, 4. Okay. So that means it's going to be like this. Oops, let's take that out. That wasn't very good. So there's that one. So that's this piece right here. And then from here, it's going to go up to here. Okay, and then from here, it's going to go down like that. Okay. So we see it down to the green. All right, last piece. Last piece. The function of f of x equals root x has been transformed into the function g of x -2, 3x minus 12 plus 5. Complete the following statements. The function of f of x has been transformed to the function g of x by stretching horizontally about the y-axis by a. So what I would do if I was you, I'd pull the 3 out, yeah? Yeah, so it looks like that, right? So like you said, they distribute the 3, so we're undistributing, which is pulling out. So 3, right? So what is the factor it's being stretched by, though? 1/3, right? Putting it all together now, guys. Gals. Okay. Stretching vertically about the x-axis by a factor of 2. Reflecting in the x-axis. And translating 5 units up. So remember, that negative makes it go over the x-axis. It's a vertical reflection. Okay, the 2 just stays the 2, and then the 5 units up is on the end. Okay, the last thing it does, go ahead and use 4 units horizontally to the right. All right, guys, that's it for lesson 8. All right, so now